So as we know, in last class, we studied about rolling series. That's our translation plus rotational motion, how to calculate the displacement and as well as velocity. So now, and we have been formed the two formulas for displacement and as well as velocity. And today's class, we are going to make acceleration, and then further we are going to continue. What is the expression for a body which is in translation for unrotational motion? Like when the body is in translation plus rotational motion, that's what rolling. So what is the expression for MOI? That's what moment of inertia, and as well as kinetic energy, and as well as angular momentum. Okay, everybody. So that is what is our target in our today's class. So as we know, in last class we discussed, we have done the formula to calculate the displacement of a particle with respect to ground, which is equals to, what is the formula we have got it, everybody? Displacement of a particle with respect to ground, which is equals to what? Displacement of a, yes please, center of mass with respect to ground plus displacement of a particle with respect to center of mass. So next, velocity of a particle with respect to ground, which is equals to what, guys, everybody? Velocity of a particle with respect to ground. Yes, please. Velocity of a particle with respect to ground is equals to, we all know, velocity of center of mass with respect to ground. Is there anybody in meeting? Only I myself, I need to speak. Which is plus velocity of a particle with respect to center of mass. So these are the two things we already made it. Now, in our today's class, we are going to make next acceleration of a particle with respect to ground, which is equals to, again, same thing, acceleration of a center of mass with respect to ground plus acceleration of a particle with respect to what, everybody?
Center of mass.
With respect to center of mass. So these are the things we are going to discuss now. So let us start with a thing which we already know. So let me consider there will be a disk, or you can take it as a disk I'm taking. So one person who is observing from the ground, that is what, with respect to ground. So there is a COM, center of mass, who's having a velocity or acceleration now. It's not velocity. So acceleration of a center of mass is A. So now, and radius, let me take, this is the radius R. Now if you observe, I am choosing a particle and it is rotating with angular velocity omega and angular acceleration. What is angular acceleration, everybody? Angular acceleration is what? Yeah, alpha. It is what acceleration? Centripetal acceleration. So if you have taken here, all of you, whenever the body is rotating here, right now I want to calculate the acceleration of this particle. So we all studied that if you have taken any particle in the circular motion, you can see. So here always two accelerations are acting. One is towards to the center, which we used to call as what? Centripetal acceleration. Another one is tangential acceleration. That is what, AT. Am I right, guys? Everybody? And what is the angle between them? Always the angle between them is how much? Everybody? 90. Understand? So now if I have taken here, so this is the particle P I have been taken. So what is the acceleration acting here? Not one acceleration acting. So how many accelerations are acting, everyone? It is two accelerations are acting. So one acceleration which is acting towards to the center. What is that acceleration called as, everybody? Centripetal acceleration. And another acceleration is what? Here,
Tangential
acceleration, acceleration of center of mass is there, and another acceleration is what, everybody? Acceleration of, that is what, tangential acceleration. Are you clear, everybody? A tangential acceleration. Now, if I take any kind of particle, so we all knows that centripetal acceleration is equals to, what is the formula? R omega square, and tangential acceleration equals to, what is the formula, guys? We all knows that. Anybody? R alpha. Am I right, everyone? They already knows. Correct? Please
Yes,
respond. That is what. So if I take the acceleration of a particle P, any particle P, if I choose, so whatever the acceleration of center of mass, every particle is having the same acceleration. That is what is the forward direction. That is the acceleration of center of mass. And now here one more acceleration is acting. What is that acceleration? tangential acceleration, and another acceleration which is acting towards the what? Center. What is that acceleration? Centripetal. Yes, please. Towards the center, centripetal acceleration. So these are the accelerations acting on a point P. So if I take now, what is the net acceleration, everybody? Net acceleration is equals to what? Acceleration of center of mass plus centripetal acceleration plus tangential acceleration. So this is what is actually the net acceleration. That is what you have to understand. I hope you all clear, everybody. So for any particle, if you have taken, this is what is the thing which will happen for the acceleration time. Is it okay, everyone?
Yes, sir.
So brothers, understand? With respect to ground. Narayan?
Sir.
Yeah, that's what it is now. Okay. So with respect to ground, if you want to find the particles acceleration with respect to ground, so which is equals to centripetal acceleration through the center. That is what? Acceleration of a C with respect to ground plus acceleration of a particle with respect to center. So that is what is the formula. So now with the help of this is what is acceleration concept. For every point, it will be always there. So and always remember centripetal acceleration is equals to radius into omega square, and tangential acceleration equals to, we all knows that. What is that? R alpha. Clear, everyone? That is what you have to remember. Now, so finally I can say is that acceleration of a particle with respect to ground, just I will say that acceleration of a center with respect to ground plus acceleration of a particle with respect to center. This is what is the formula for acceleration. So that's all it is. Now let me take question. You can take it. So let me take, there is a disk. So whose angular acceleration is 2 radians per second square. What is the acceleration, everybody? 2 radians per second square. Now, whose center acceleration of center of mass, which is equals to, so let me take 5 meter per second square, and the radius of the track is 2 meters, and angular velocity is equals to 3 radians per second. So this is what is the given data. Now, so please kindly find it. So how to do it, everybody? Can you tell me? So we all knows that what is the acceleration formula, everyone? You can notice it. It is sum of the 3 accelerations. What is the net acceleration, all of you? Net acceleration, 3 accelerations. So net acceleration is equals to, what are the 3 accelerations? Please respond. One is, everybody, one is acceleration of center of mass. Already they have
Center
given.
of mass.
Yeah, what is the acceleration of center of mass? 5 plus acceleration of centripetal center, so the centripetal acceleration plus tangential acceleration. First, let me find centripetal acceleration, r omega square. What is r value, everybody? R value is how much?
2, sir.
2
Yes.
meters.
So all of you see that r value is 2, and you can take omega is equals to how much? 3 square. So which is equals to what, everyone? 2 into 9, which is equals to how
18.
much? Huh? 9 2, so yes.
18.
So 18 it is centripetal acceleration. Next, tangential acceleration. Oh, so tangential acceleration. 80 is equals to r alpha. So r is 2. Alpha is equals to also 2, which is equals to what is the tangential acceleration, everybody? 4, understanding? So 4 meter per second, whatever it is. Now, if you observe, all of you, along the tangential acceleration, if you notice it basically, so if I take the particle P, oh sorry, I forgot the particle P here. So this is the particle P, we have to find the acceleration of it. So what is happening, all of you see that here 2 accelerations are acting. One is tangential acceleration, and which is acting downwards. What is the acceleration we used to call as? Please respond. Centripetal acceleration. And there is one more acceleration which is acting along the same point. What is that? Acceleration of a center of mass. Acceleration of a, yes please, acceleration of a center of mass. So that is very important. So if you have noticed it here, if I choose the particle P, so acceleration which is acting towards to the center, which is equals to how much actually? 18. Okay. Now there is a 2 accelerations acting on the same. One is tangential acceleration. What is the tangential acceleration, everybody? 4. And what is the centripetal, acceleration through center of mass, which is equals to how much, guys? Everybody, 5 meter per second square. Understand? So what will happen? This both 5 plus 4, which is equals to how much? Net, that both are acting same direction. So addition. So 5 plus 4, 9. And this is 18. So net acceleration will act what? Everybody. Where is the net acceleration act? Between them. Am I right or wrong? Please respond. So if you want to find the net acceleration, what is the formula? Root over a square plus b square. So over 18 square plus 9 square. So what is 18 square? Verify it, everybody. 18 square.
324.
Yes?
324.
324. So 18 square, 324, 9 square, 81. Totally how much for those? So 324 plus it is 8 square, 91. So which is equals to how much answer?
405.
Yeah. So that is the answer. So root over 405. That is the net acceleration. So please make sure. So that is how you have to calculate the acceleration of any kind of particle in the motion, circular motion. That's what translation plus rotational motion. Are you clear, everyone? Hope everybody clear. Mr. Narayan, understand? Pradosh, Kadri, that's what. Solve it. Any doubt? We will do it now fastly. Understand, Pradosh?
Yes, sir.
Where is Sai Karthik? Sai Karthik having practice, I think. Okay. Mr. Rohit, understand? Rishi?
Yes, sir.
Your brother is doing or not?
Yes, sir.
Pradeep, understand, Narayan? Anything doubt, Narayan, in this? You can ask. Okay. Complete, Ishwali?
Yes, sir.
Okay. So next, we are going to start next one. We are going to derive the formula or relation for translation and rotational motion. When it is translation plus rotational, what is the MOI, moment of inertia expression, and what is the kinetic energy expression? So keep reading next one. So rolling series 2. Okay. So moment of inertia and kinetic energy. And evening we will study angular momentum and we'll solve the numerical solves. So kinetic energy expression, you can keep L also, expression for translation plus rotation. So what do you mean by translation plus rotation, which we used to call as rolling? So translation plus rotational, what is the MOI, moment of inertia of a body? Or same way, what is the kinetic energy of the body? That is what we will discuss it. Is it okay, everyone? Clear? Shall we start? All of you?
Yes, sir.
So now if you observe very carefully, so if you notice it, suppose let me take there is a disk, if you have noticed it. So which is traveling with the velocity of the center of mass is V and having a mass of capital M and angular velocity omega. Angular velocity what? Omega. So what is the MOI? MOI means what, guys? What is MOI? Moment of inertia. So what is the moment of inertia symbol? Everybody? Moment of inertia symbol. Indra. Inertia. Yeah. Understanding? So what is the inertia formula? Moment of inertia. Everybody? Nobody knows. Rate of change of momentum. That's what it is. So moment of inertia. So first one, if you notice it here. So the first thing which we are going to find is actually what is the momentum of this one. Yes, Ishali, tell me. So MY, the momentum of a system when it is in translational plus rotational. So which is equals to mass of the body into velocity of center of mass. This is what is the momentum formula when it is in translational plus rotational motion. So let us calculate it, and let us make the proof also for this. Sorry, it is momentum. So momentum, kinetic energy, and angular momentum expression. Okay. So let's start now, everybody. So if I take everybody, so observe very carefully. So net momentum of a particle of an entire system is equals to mass of the body into velocity of the body at the center of mass. That is the formula. So we are going to derive this formula now. Okay. So if you notice it here, whenever I say P net, what do you mean by P net? It is what with respect to what? With respect to always, everybody.
Ground.
With respect to ground, we have to take it. Now, we all knows that if I take any kind of body, it is actually millions of particles are present inside that. Am I right? Will you all agree with me, everybody? So let me take it is a M1, and it is taking M2, and it is taking M3. Okay. So it is taking M4. Like that, if I make many number of particles, which is equals to what, everybody? M1 plus, M2 plus, M3 plus, and so on, which is equals to what? You should tell. We all people knows. Which is equals to what, guys? Yes, please. Total mass. Understanding? So that one point you should remember it. Now, every particle, see that angular velocity is the same, but individual velocity is not same. That is what we all people knows that. So let me try. If I take the P net is equals to proof, guys. P net is equals to, that's what with respect to ground, momentum is equals to momentum of this particle, momentum of this particle, momentum of this particle, momentum of this particle. It is like hundreds of particles we can take. So what is the momentum of first particle? Anybody? M1 mass. What is the momentum of first particle? Yes, Pradosh? You also tell me now. M1 V1. V1 is a what? With respect to what? Velocity with respect to what, Pradosh? With respect to ground. Yeah? Plus, I take M2. Yes, everybody tell me M2 is equals to what?
M2V2G.
With respect to ground. Plus next one.
M3V3G.
respect to ground, with respect to ground, and so on. Clear, everyone? So now, if I have noticed it very carefully here, so all of you observe very carefully. So we all knows that velocity of any particle, let me take, we have written already before, velocity of a particle with respect to center of mass, which is equals to what? Velocity of a particle with respect to ground minus velocity of a center with respect to ground. So we want now velocity of a particle with respect to ground, which is equals to what is the formula? Everybody respond, guys. Which is equals to what? Velocity of a particle with respect to center of mass plus velocity of a center with respect to ground. That is what we have been done. Am I right, guys? Please respond.
Yes, sir.
Now in place of P, I will take particle. V1, that is a one particle. So V1 particle with respect to ground, which is equals to what, guys? Speak loudly. Velocity of a first particle with respect to ground is equals to what? Velocity of a first particle with respect to center of mass plus velocity of a center of mass with respect to ground. Will you all agree with me? Or else I can write reverse.
Yes.
Anybody having any doubt, you can ask me. Clear, guys? Now same way, second particle. If I take second particle, tell me with respect to ground. Everybody, you should tell me. Velocity of a center of mass with respect to ground plus velocity of a second particle with respect to center of mass. Clear? Everyone,
Yes, sir.
that is
Yes,
what.
sir.
So everywhere I can take it, you can notice it. In place of M1, and in place of velocity of a particle 1 with respect to ground, which is equals to what? Velocity of a particle with respect to ground, which is equals to what? Speak loudly. Yeah, velocity of a particle with respect to center of mass. Let me modify this. Yeah, velocity of a center of mass with respect to ground plus velocity of a particle 1 with respect to center of mass plus, slowly you solve, no problem. Second, M2 into, what is the V2Z? Everybody speak here. Velocity of a center of mass with respect to ground plus velocity of a second particle with respect to center of mass plus, same way, M3 into velocity of a center of mass with respect to ground plus, speak ra, velocity of a third particle with respect to center of mass, and so on. Any problem for anybody? You can ask. Are you clear, everyone? Yes?
Yes, sir.
Yeah. Now you notice it. So multiply with everything. You can see everywhere. You all can observe very carefully. So I can write this equation into two different ways. Let us write it. Just you can make it. multiply with m1. So tell me everybody, m1 into velocity of a center of mass with respect to ground into, sorry, into not plus. Sorry, you should speak guys step by step. I am writing and I am giving the clue. Next, what will happen? Plus m1 into, what will happen? Velocity of a particle 1 with respect to center of mass.
Center of mass.
That is what. Clear? Next, second one. m2 into velocity of a center of mass with respect to ground plus m2 into velocity of a second particle with respect to center of mass. Will you all agree with me, everyone?
Yes, sir.
Yes, sir.
Next, like the same way, m3 into velocity of a center of mass with respect to ground plus velocity of a, that is what, m3, correct? Yeah, sorry, m3 into velocity of a third particle with respect to center of mass. So that is what we have. Now everywhere something is common, you can take it outside. That all together we can write it. What is that? Anybody? Velocity of a center of mass
Center
with
of
respect
mass with
to.
respect to ground.
So from this one, and this one, can I take it as a velocity of a center of mass with respect to ground separately, and remaining all I will write it as m1 plus m2 plus m3 plus and so on. Is it okay, guys? Everybody? Plus remaining one, what is there? m1 v1c plus m2 v2c plus m3 v3c. Is it okay, guys? Everyone? Plus and so on. Is it yes or no?
Yes, sir.
Sir, for those understand or clear?
Yes, sir.
Now, beginning itself, I told sum of the individual particles, which is equals to what? Sum of the individual
Total
particles
mass.
equals to what? Everybody, total mass. So, can I write this one as a m into v VCC? Any problem for anybody? Yes, please. VCC. What is that? VCO. That is what? Center of. So, what is the velocity of a center of mass with respect to ground, which is equals to what? Velocity of a center of mass with respect to ground, which is equals to what? Velocity of center of mass. Do you understand, everybody? So velocity of center of mass means velocity of center of mass with respect to ground only. So I will write COM plus, this is very important, observe very carefully, m1 v1c plus m2 v2c plus, okay, next m3 v3c plus and so on. Any problem for anyone? I want to know. Clear, everybody? Please respond.
Yes, sir. Yes, sir.
Now observe very carefully. I am going to say you one important thing. Let me take now two particles. This particle is m1. This particle is m2. This particle velocity is v1g. This particle velocity is v2g with respect to ground. Purima. Now, can you tell me, we already studied long back, what is the velocity of center of mass formula? Anybody? Rudreswar? Velocity of center of mass formula. How we can get? Sum of all the individual particles divided by total mass. Am I right or wrong? Yes, please. So
Yes,
m1 v1, momentum of every particle divided by total mass. m1 v1 plus m2 v2. With 2, I am not leaving the ground. If I put the g, what is that? With respect to what? Always. With respect to ground. And m3 v3g, like that, keep on showing. Divided by, I will write m1 plus m2 plus m3 plus and so on. Any problem for anybody? Everyone? Please respond, guys. Yes? All of you?
Yes, sir.
Yeah.
Yes, sir.
Now, observe very carefully. So why I am doing this, why I am explaining this one? This whole term, can I divide and multiply with the capital M? Any problem for anybody? I am dividing and multiplying both with the same M term. Any problem? Yes, please. All of you?
No, sir.
No. So, because why I am saying means, we all knows that capital M means what? Capital M means what? Sum of the individual masses. M1 plus, M2 plus, M3 plus, and so on. That is what is the capital M. So that is what I am taking. So, if you all notice it, so velocity of center of mass, which is equals to, this is only correct. Sorry, not C, G here, C. So that is equals to VCOM. Am I right or wrong, guys? Verified basically. Basically, it is at G, okay, with respect to ground only. So, but here we are having COM, but here we are having through the center of mass. This is with respect to ground. With respect to ground, we know the formula. M1 individual momentum divided by total mass. Now here we are having what? Everybody, verify it. This whole thing, forget about the M. This whole thing is equals to velocity of center of mass. Will you all agree with me? Am I right or wrong? Yes?
Yes.
But this formula is what? With respect to what, everybody? This is with respect to what? With respect to what it is? This is with respect to
Ground.
ground. But here with respect to what? Here with respect to what? Center of mass.
Center of mass.
Understanding? So, M into V center of mass plus this whole thing I will write it as a velocity of a center of mass. Again with respect to what? With respect to ground or with respect to center of mass? Velocity of a center of mass with respect to what, guys? With respect to center of mass into capital M. So, now you tell me, in the given question, all of you observe, what do you mean by VCM? Everybody try to answer. What do you mean by VCOM? Velocity of a center of mass with respect to what? Everybody. With respect to what? Everybody.
Ground.
With respect to ground. But now we got velocity of a center of mass with respect to center of mass. How it will be? So with velocity of a center of mass with respect to ground, it will be existed. But velocity of a center of mass with respect to center of mass, it is not existed. So that this whole term will become what? Everybody, 0. So finally, the net momentum is equals to M into VCOM. That is the formula. Once again, I will say you, all of you observe. If I take any two particle in a system, just imagine, let me take three particle. So this momentum is, velocity is V1 with respect to ground. With this velocity is V2 with respect to ground. This velocity is V3 with respect to ground. So if I find the total velocity of through center of mass, which is equals to what? M1, this is M1, this is M2, this is M3. So M1 V1 with respect to ground plus M2 V2 with respect to ground plus M3 V3 with respect to ground plus so on, divided by M1 plus M2 plus M3 plus M3 plus and so on. So we all knows that this is total thing is equals to what, guys? This total thing is equals to what? Everybody, please respond. Capital. Understanding? So total mass, which is equals to, can I write this one as a M1 V1 G plus M2 V2 G plus M3 V3 G. So this is actually what? Actually, everyone, this is the total, understanding? Total, sorry, velocity of a center of mass with respect to what? This is the velocity of a center of mass with respect to what, everybody? Ground actually. So then it is existed. So divided by M. So that is why I am multiplying both numerator and denominator in this case. Both numerator and denominator with the M, capital M. So I am replacing M means M1 plus M2 plus M3 and all. So just I am simply taking. But if you notice it here, M1 V1 C. But here we have what? M1 V1 G. This is momentum with respect to center of mass. This is momentum with respect to what? Ground it is. Do you understand, everybody? So what will happen? Everything is same. So velocity of center of mass with respect to ground means this is the formula we know. But here we are having velocity of center of mass with respect to center of mass. So that is why no velocity is existed with respect to center of velocity. So center of mass. So that is why it is 0. With respect to ground only every velocity is existed. So suppose, as we know, if I am sitting on the center of mass, is it I am having any velocity? If I am on the surface with respect to ground, I can see that yes, it is rotating. If I am also sitting on the surface, am I having any velocity? Please respond. Yes, please.
No,
if
sir.
a person is sitting inside that, is it having any velocity? No. So with respect to center of velocity of a center of mass is always 0. So that's all. What is the final formula for net? Net momentum is equals, everybody? Yes, please. Net momentum is equals to mass of the body into velocity of COM. That's all it is. So please solve it. Anybody having any doubt, you can ask me. Rudresh, or clear? So P net is equals to mass into velocity of center of mass. Mr. Narayan, Pradosh, anywhere doubt, you can ask. Understood? Adra. Kadri? Brother solving ara?
Sir.
Any doubt you can ask me. Rudreshwar, what happened late? Okay, solve completed. Mr. Pradeep, understand, Pradeep? Here you have to write it. Both numerator and denominator we have to multiply with what? Capital M. Okay. So that is what you have to remember. Capital M means what? Sum of the individual masses. M1 plus, M2 plus, M3 plus, and so on. That's what it is. So remember all of you, velocity of center of mass means with respect to ground. It is existed. That is what? Velocity of center of mass with respect to center of mass is 0. That's all it is. So that it is, this whole term will become 0. So we'll get net. That's what momentum is equals to mass into velocity of center of mass. This is velocity of center of mass with respect to what? With respect to ground. Okay. That is what you have to remember it. So anybody having any doubt in this, you can ask me. So or else we'll go to the second one. That is what? Kinetic energy. So we all people knows kinetic energy formulas. Just if it is a linear motion, what is the kinetic energy formula? That is what translation motion. Please speak loudly, everybody. What is the kinetic energy formula? Half m v square. If it is the rotational motion, we already knows what is the kinetic energy formula. Last already we derived. Anybody? Yes, please. Half into here mass, here inertia, here velocity, here angular velocity. That's all. So this is only the thing now. So what is the kinetic energy of expression for kinetic energy of a rolling motion? Rolling motion means it is a mixed motion, both translational motion plus what motion it has? Everybody, rotational motion. Yeah. So it will be also containing hundreds of particles. So we all know that. So many particles it is present. So we have what is the relationship between velocity and angular velocity relation? Anybody can tell? So radius is r. Radius is r. So what is the relationship between velocity and angular velocity?
R omega.
R omega.
R omega. Okay. Rudreswar, have you solved before one? Have you understand or not?
Yes, sir.
Okay. So that's what. Here, just only one thing you remember. Velocity of center of mass with respect to ground is, that is what VCOM. But here we are having not G, we are having C. That is why I'm just replacing velocity of center of mass with respect to center of mass again there. That is why it is become 0. So that's all. It is nothing else. Okay. So it's not existed. Now we are going to derive the expression for kinetic energy. So having a rotational motion plus translation motion, having a radius r, angular velocity omega, and center of mass velocity is v. So now, and total mass is m. So what is the relationship between v and omega? Anybody? V is equals to what? Everybody?
R omega.
R omega.
So expression for total kinetic energy in translation plus rotation is equals to sum of the translational plus rotation. That's all. So kinetic energy in translation motion plus kinetic energy in rotational motion. So what is the kinetic energy in translation motion? Everybody make it fast. Half into m v c o m. V means what? Center velocity of center of mass with respect to what? Ground. Clear?
Ground.
Plus I in half into I into omega square. This is the expression for total kinetic energy in translational plus rotational motion. So we are going to derive it now. So make everything clear. If any small doubt also, please kindly ask me so that I will explain it. So I have considered hundreds of particles are existed, so that we are need total kinetic energy. So total kinetic energy equals to what, guys? Sum of the individual energy. So every particle is having translation energy plus as well as it is having what energy? Everyone? Yes, please. It is also having what? It is having translational energy plus what energy? Rotational energy. Understanding both motion it is. So kinetic energy of first particle. Let me take this is m1. So can you tell me what is m1 particle? Half into m1 into v1 square plus. I am taking here another particle m2. Speak loudly, everybody. Half into. Yes, please respond. m2 into. Yes.
V2 square.
Yeah, m2 into v2 square plus I will take another particle. 3 particles, let us go with that. m3. Now tell me m3 is equals to what will happen? Everyone?
M3 V3.
3v3 square.
M3 V3 square. See, this entirely you only should tell. Then only I can do it very simply. So plus and so on, like that infinity number of particles. So we all know velocity expression. Can you tell me? Velocity of a particle with respect to ground is equals to. Velocity of a particle with respect to ground is equals to. What is that? Velocity of center of mass with respect to ground plus velocity of a particle with respect to center of mass. Am I right, guys? So in
Yes, sir.
particle, I am replacing now one first particle. Velocity of particle 1 with respect to ground, which is equals to what? Everyone. Velocity of particle with respect to ground is equals to velocity of a center of mass with respect to ground plus velocity of a particle 1 with respect to center of mass. Velocity of a second particle with respect to ground, which is equals to what? Velocity of a center of mass with respect to ground plus velocity of a second particle with respect to center of mass. So here I am writing velocity. Can you tell me it is what? With respect to ground or with respect to center of mass? With respect to everybody. With respect to
Ground.
what? Ground. So I will replace everything half into M1 into V1 square. What do you mean by V1 square? Everyone. What is that? VC plus V1C, which is G. V1C whole square plus next. Speak loudly. Everyone. Second one, half into M2 into V2 means what? VCG plus V2C
V2C square.
plus. Let it be 2 is enough for us. We'll go with the head. So now half into M1 into. This is A plus B whole square. You all know itself, you tell me. A plus B whole square. What will happen? All of you. Yes. So we all knows that one more thing. If it is a rotational motion, angular velocity remains constant, but translation velocity V1 is it constant for every particle? It is not constant. Yesterday already we calculated. Am I right or wrong? Yes, please. Please respond, guys. Every
Yes,
particle angular velocity remains constant, but individual velocity V1 is not equals to V2 is not equals to V3. Yesterday we have calculated or not, guys? Everyone?